Okay, so the question says that you will be given an integer n, okay, and you have to check that how many bits, you have to return how many bits are on. On means 1. Okay, in how much time can you solve this question? If this is a long integer? In 64 times. So what you can do is you can just, how many of you are thinking like that? That I'll run a while loop, I'll keep taking remainder with 2 and dividing by 2. And then I'll keep checking whether the remainder is 1 or not. Will that approach work or not? Tell me that. That approach should just work fine, right? Because that is how you generate binary representation of a number, right? So for any number, you can simply generate its binary representation and just check the number of times 1 has come. And in the process of doing that, you will simply check for the number to get converted to something like 0. So what would have been the time complexity of that approach? The time complexity of that approach would have been log of n base 2, right? Log of n base 2. And log of n base 2 can at max be something like 64, because n cannot be more than 2 raised to power 64 in case of long integer, right? So this is one way. Okay, how many of you have thought of using a bit mask? You can use a bit mask also and get your job done. So let's say the number is of this representation 1011001, and then everything here is 0. So you can start with a bit mask, okay, and that bit mask will be something to start with where there will be 1 over here, and then 0 0 0 0 0 0 0, everything 0, and then you will take AND of that bit mask with this, and then you will check whether the result of that is non-zero or not, okay, and then you would want another bit mask where this is 1 and everything else is 0, and then you would want another bit mask where this. So for all these bit masks till the last bit mask, which will be this, where everything is 0, just this is 1. So with all these bit masks, you will take the AND of this, and the moment the AND is coming out to be non-zero, that means that at that particular bit position there is 1. Why so many ANDs? Then how will you check? How will you check? So first you would want to check whether the 64th bit is 1 or not. Sorry, 63rd bit is 1 or not. For that, you would want to take AND with this. Then you would want to check, but tell me, is that it? Is that the only thing that you want to do? To check whether 63rd bit is on or not? No. You want to check whether 62nd bit is on or not. For that, you take AND with this, correct? Right? And then with this. And so on and on and on and on, right? So to start with, what will you do? You'd create a long int mask, which would be something like 1 left shifted by 63 units. And then tell me one thing, what is a very fast way of coming from here to here? If mask is this much, how do you convert mask into something like this very quickly? By just doing a right shift. Is that clear to everyone? No. No need of doing that again, because left shift by 62 units is costlier than right shift just by 1 unit. So instead of doing that, just do right shift by 1 unit. So right shift is very powerful in these kind of scenarios where you want to change your masks quickly, right? So now what can you do? Okay, for what value of mask will you want to terminate? So when the mask becomes 0, you will want to terminate. So you initialize your count of bits, which is 0. Now as long as your mask is a non-zero mask, what will you do? You will take the AND of this mask with the given number. So if mask and that number num, if this thing is non-zero, you will do count plus plus, and after doing this you will shift your mask, right shift by 1 unit, right? And whatever is the count, that will be finally returned. So every code you write today, you have to use these operators only and nothing else, right? Yeah, so what is the time complexity of this? So here you always start with the 63rd bit position. So the time complexity of this is always order 64. So now in certain interviews there is a constraint which is being put. The constraint is that, hey, your algorithm should run in this much time, order of number of on bits. On bits are also called as set bits. So it should run in order of number of set bits. So let's say if there is a number whose bit representation is like this. So how many bits are on? 1, 2, 3, 4. Just 4 bits are on out of 9 bits. So the expectation is that you should just do order 4 looping. So let us just understand one thing. Let's say there is a number like 1000. Okay. If I subtract 1 from here, what will I get? 0,111, right? Okay. If you take any other example, let's say if you have 100 and then you subtract 1, what will you get? You will get 011. So here you got 0,111 and here you got 011. What will you get for this? You will get 01. So do you understand this thing clearly? If you are taking, okay, these numbers that I have taken are powers of 2. These numbers are powers of 2. So if you subtract 1 from a power of 2, you get 0 followed by many numbers, 0 followed by all the bits as 1. I think this is quite easy to understand. So if let's say there is a number like this which has all ones, and if you add a 1 over here, this becomes 0. Then again this becomes 0, then again this becomes 0, then again this becomes 0, then a 1 comes over here. Okay. Also, if this is like 2 raised to power I, then this is 2 raised to power I minus 1. Okay, because this essentially is sum of a geometric progression, 1 plus 2 square, so on till 2 raised to power I minus 1, and this is 2 raised to power I minus 1. So what I am trying to say is that if you subtract 1 from a number like this, then it becomes something like this. Now tell me one thing, if a number is a power of 2, if that number is x, and I take x and x minus 1, can you tell me what will be the result? X is a power of 2 and then I am doing x and x minus 1. What will be the result? It will be 0. And why that is becoming 0? That is becoming 0 because of this trend. Because the moment you do minus 1 from here, you will get this bit becoming 0 and all these bits becoming 1. Since this has become 0, this will evaporate this. And all of these were initially 0, so they will themselves get evaporated, right? Now just come over here. So now let's take a number which is something like this, 10110 0, and let's say there is one more 0 over here. Okay, if you do a minus 1 over here, what will you get? Can somebody tell me? Yeah, so look at the board, everyone look at the board very closely. So if you do a minus 1 over here, instead of focusing on the entire number, just focus on this much of number, because focusing on this much of number means that start moving from here and once you encounter the first bit which is 1, just stop there. So this thing is 100, which is 4, and if a minus 1 is done for 100, can you tell me how much do you get? Do you get 011, right? So if you do a minus 1 on this entire number, this will get converted to 101 0011. Now if you take a AND of this and this, then this prefix will completely get evaporated. If you take AND of this and this prefix will completely get evaporated and this will become something like this. Whatever you did for this number, now you do for this number. So now this is my number, and now if you subtract 1 from this, what will you get? So if you just look at this much portion, then you will have a 0 here and everything else will be 1. And now if you take an AND of these two, what will you get after taking AND of these two? Yeah, so this entire prefix that you see over here will get evaporated. So 1 followed by this 0 will be there, and then 5 times 0. Okay, now again when you take this number and then you do a minus 1. If you do a minus 1 at this point of time, what will you get? You will get 0 followed by 6 times 1. And once you take an AND of this, what will you get? You will get all zeros. And now here you terminate. So how many iterations of this thing has happened? Can I say that the number of iterations is simply equal to the number of set bits? Yes. Why? Because the zeros which are sandwiched in between, they will get ignored. So all that you have to do is, every time you have to do n mod n minus 1, as long as n doesn't convert to 0. So you can write something like this: while n, you can do something like this, while n count plus plus, and then you convert n to n and n minus 1, and then finally just return count. Right? So I want you guys to, yeah, what is the time complexity of this? The time complexity of this is simply equal to order of number of set bits. So an important thing to understand over here is that trend. And what is that trend? If a number is like this, a power of 2, and if you subtract a 1 from there, you get something like this. This is very important trend, and this will be quite helpful in upcoming questions. Okay, while you are using this approach, I will tell you that while you are solving this particular question, solve it using this approach as well as the other approach. So this is mask based approach and this is that tricky approach. Okay, so solve using both of them. Okay, while you solve it using both of them, you have to be wary about one thing over here. This 1 should be 1L, otherwise it will overflow, and I told you why. Okay, cool.